what would I have to go through to get there? Through the pericardial sac. Yeah. So the parietal pericardium must be cut, and then an incision has to be made along the tissue on the edge, the outer edge of the heart, the visceral pericardium, because the blood vessel is tucked in the sulcus inside that. There has to be a cut made in the epicardium to get your hands on the blood vessel, protected inside this balloon that the heart is sitting inside, the pericardial sac, visceral and parietal. Here's some x-rays where you can see whatever has caused the issue here for the congestive heart failure has caused massive amounts of pressure to develop within the heart. And even a novice like me and you, clinical novices, can look and see the outline of the heart here. You see the darker portion of the outline of the heart here. And you can see on this picture what has happened. What is inside the pericardial space now? There's extra fluid in there. And it is causing a massive amount of problems with the beating of the ventricles. And so the muscle mass responds to this by overproducing myocardial cells, and grows and begins to reduce the amount of volume that the ventricles hold, causing all kinds of problems with blood flow. This is normally why congestive heart failure is fatal, because the heart is working itself so hard because the perfusion pressures in the body cannot be maintained, because you can't pump enough blood out of the left ventricle with each heartbeat because of the strain, the pressure that has been put on the mass by fluid that is accumulated within the pericardial sac. Okay, so it's a very important clinical spot here between the visceral and parietal pericardium. All right, here's the third one. This is the peritoneum. And again, this is a little more detail than Miriam gives in her text here. But I know this is important for your lives, so let's get it right now at the beginning. So every time it comes up, it's reviewed. All right, so the image in the student's head about pleura and pericardium normally does not cause a problem. When I show the costodiaphragmatic recess, everybody goes, okay, I got you. That's the space there on top of the diaphragm. That's where the fluid would collect. I could see that in an image. Somebody with congestive heart failure, I can see the swollen heart there, the fluid within the pericardial sac. That is something I can tangibly get my hands on, okay. But now what you're telling me is that all of the organs inside here in the abdomen are also covered by a serous membrane. That is exactly what I'm saying. Now, the problem with learning it that way is many structures within the abdominal body cavity develop in their embryological development in such a way so that they end up behind this bag. They end up behind the protective peritoneum. And those are extremely important clinical things to know. It answers all kinds of questions about kidneys and colon, and I'm going to show you a couple pictures to really drive that point home for you. Okay, so what I want to say is this. It is true that the peritoneum develops in the similar fashion that the pericardium and the pleural membranes, serous membranes, develop. And the organs within this abdominal body cavity develop within that peritoneum. And just like the pleura offers a lubricated protective house for the lungs to work in, and the pericardium provides a lubricated protective bag within which the heart can beat, the peritoneum provides a lubricated protective bag for the organs of the digestive system to move around in. So, you can take a stethoscope and you can listen to the lungs. And if you get crackling noises, you can tell there's fluid inside there. Something is wrong. You can listen to the heartbeat. And if there are unusual noises there between the beats, you can tell there's a problem there. You can also tell there are problems in the digestive system by listening there. So the digestive system actually moves around inside this peritoneal bag and protects these organs. It serves as a lubricated sac within which these organs can move. During the last test section of this class, I'm going to show you this picture one more time before you leave me. But in that context, I'm going to tell you about the muscular walls of these structures and how they move. So this is, I'm trying to tell you, don't let this go away from, go ahead and learn it right now. Now, the difficult part of learning how the peritoneum is arranged is to learn what pieces and parts are not inside that bag. Those pieces and parts that are not inside the bag we call retroperitoneal. That is, they are behind the peritoneum. That is, the organs have peritoneum on their anterior side only. These structures would not be suspended by the mesentery. All right, so I just used a new word. Tell you what I mean by that. Mesenteries are really ligament-like attachments that hold structures in the abdomen to other organs and to the body wall. And they all have names. They are developmental extensions of the peritoneum. So you're going to learn some of them later in the digestive system anatomy. You'll see them. If you open up, one easy one to do, you open up the cat and you lift the colon. You get your hands under the small intestine and you lift the colon. The colon is actually anchored to the dorsal body wall by a membrane, a ligament, if you will. It is actually an extension of the peritoneum, and it has a name. We call it the mesocolon. So all these structures have either ligament or mesentery names holding all these things together, and we'll learn those later, okay? We'll do it in the lab, we'll do it in the lecture, some of the names of these ligaments and mesenteries that hold things together. Okay, these are between the parietal peritoneum and the abdominal wall, and classified, these organs are classified as retroperitoneal. All right, so here is the list of the big ones, the big daddy list of structures. And then, after we learn these, I'm going to go to the images and show you the names of the body regions and where these organs are. So you have the full scope of the terminology to explain this. All right, so glands first. The adrenal, the kidney, the ureter, and the bladder all sit retroperitoneal. They're outside of this. Now, the adrenal gland and the kidney are actually in the abdominal body wall. Actually in the abdominal body cavity. The adrenals sit right on top of the kidneys. These structures sit on the dorsal, they sit on the dorsal body wall. So when you're doing a dissection of a kidney and adrenal, one of the things that jumps out at you is how much adipose tissue is there. Now why would you see additional adipose tissue around the kidneys and the adrenal gland? That doesn't seem healthy. Why is that so important? Why does the anatomy show up that way? Well, they're retroperitoneal organs. They're not inside the protective bag. So the adipose tissue develops around these organs as a cushion to protect them. So this is the story. You look at those things and you think to yourself, they're retroperitoneal. That's why all the adipose tissue is there. The ureter extends from the kidney down to the bladder. Now the bladder itself is in the pelvic body cavity. So I'm going to show you a picture so you can see what happens with the parietal peritoneum there. Like I said, your book doesn't show you that. It's an important spot. So I'm going to do that in both males and females. The ureter runs down to the bladder. Both of these structures are retroperitoneal. In this case, the ureter fits this definition quite nicely. The parietal peritoneum is on the front of it. So it sits retroperitoneal. It's on the back body wall, the ureter is. It's not inside that bag. And then the bladder is actually inferior to the parietal peritoneum. It sits under it. All right, so I'm going to show you a picture of that. blood vessels. The aorta coming out of the heart. The aorta comes out of your heart and passes behind your heart, posterior in the thoracic. Goes through the diaphragm. Now it's in the abdominal body cavity. In fact, we call it the abdominal aorta. But it is not in the peritoneum. It's on the dorsal body wall. Along with its venous counterpart, the inferior vena cava. These two blood vessels sit outside the peritoneal bag. Now the first part of the small intestine, I'm working my way down. The first part of the small intestine is called the duodenum, or the duodenum. And most of this structure, for developmental reasons, embryological reasons, sit outside. It sits outside. The first piece sits outside the peritoneum. Now, make a mental note here. Like I said, I'm going to show you these pictures so you really get a sense of all these organs. I'm putting the terms in your head, and then I'm going to show you the pictures. The pancreas, it says here, it says the head and the neck and the body, but the tail is in. So what you're seeing here is the main mass of this organ, the pancreas, is retroperitoneal. Now, that's not going to be surprising, and here's why, and where the structures are. If you want to find a pancreas, you find the duodenum. The stomach attaches to the duodenum and the abdominal body cavity. The stomach is in. It is inside the bag. But as the stomach comes off the pylorus of the stomach and loops outside of the stomach, structures pass into that first piece of small intestine. That first few inches of the small intestine goes behind the peritoneal bag. It's not in the peritoneum. And attached to that duodenum is the pancreas. Most people think about the pancreas first in terms of sugar regulation. But you could make the case the pancreas is as important, if not more important, for the digestive system because it is attached to the duodenum. The pancreas is linked there. Retroperitoneal, behind the peritoneum. The colon has three sections: an ascending, a transverse, and a descending. The ascending and the descending portions of the colon are retroperitoneal. We need to see that. They're behind the peritoneum. The cecum, which is where the small and large intestine meet, and the transverse colon are actually inside. So the little bag there where the appendix is attached actually sits inside the peritoneal cavity. Why would you point that out, Wade? Where are you going with this? So the small intestine attaches to the large, and there's a bag, a little swollen piece. And there's a little worm-like structure attached to it called the appendix. The cecum and the transverse are in, which means the appendix is in. So is your appendix inside the bag or outside the bag? It's inside the bag. Why would that be important? If your appendix blows up, a lot of people have appendicitis, things that blow up, and they manage to survive that. How does your body manage to contain all of that digestive muck within that area? Because of the peritoneal arrangement there, because of the membranes that surround it. And then ultimately, the omentum helps as well with the lymphatic tissue. But I'm just trying to put all these images in your head. Now let's look at them. Yeah? Let's look at them together. So, first question I want to show you, first thing, this is not in your book, but this is a picture very low in the female body. So you can see here the uterus labeled here. First of all, what kind of section is this?
Sagittal.
This is a sagittal section. Does everybody see that?
Oh my God.
This is a sagittal section of the bottom of the female body right here. There's the rectum. Is it inside the peritoneum or out? It is outside. That is your descending or terminal portion of your colon, the rectum. It's outside. So, the bag, right? Up here is the abdominal body cavity and the bag. And so, I've got visceral covering the organs and parietal on the outside of those things. So, I want to get into the stomach or whatever, I got to go through that bag. Okay, when I get down to the pelvic body cavity, this structure, the uterus, and this structure, the bladder, and this structure, the rectum, are in the pelvic body cavity, and you could not get to them by opening the abdominal body cavity. What would you need to do to get to them? You'd have to cut through something, and what would that be? So this layer right here, looping across the fundus of the uterus here, forming a little pouch between the uterus and the bladder, and then across the top of the bladder here. It then turns here and runs along this way. So this structure, the descending colon and rectum, are posterior to that. They're retroperitoneal. And I told you that the bladder is also retroperitoneal, but it is actually inferior to this membrane. So what would I need to cut through in order to get to